motions of 40 revolutions of stars, galaxies, okay, galaxies, and then galaxies, and the whole cosmos, the whole cosmos. Okay? So that's all about the first subtopic of introduction. I believe you enjoyed it. It doesn't mean that that's what I know about the introductions of gravitation. I know a lot, but according to the boundaries of the syllabus, I cannot even go further to what I've taught. This is even more than what I should teach you. So it's not, but I don't limit you to look more than what I've introduced it to you, right? So now we are going to the second subtopic. So go to your reference. How did they name the second subtopic? Astronomers what? Theorems. That's the point that we are going right now. Number 3, number 2. So I can just even name that. This is in syllabus, is the 5th chapter, so in mechanics. So I can name even 5.2. This means that this subtopic, we call it astronomers theorem. Astronomers theorems, plural. Astronomers theorems. Okay. First of all, what the meanings of the word astronomer? It's a new term for you. The word astronomer, what does it mean? Astronomer is the person who used to study astronomy. Just like in physics. A person who studied physics, we call him a physicist. A person who used to teach, we call him a teacher. A person who used to lead, we call him a leader. A person who used to manage things, we call him a manager. So astronomer, it means that this is the person who spent or did a lot of research on the subject of subjects of astronomers. So we say that in mechanics, when you say mechanics and gravitation, there are three important theorems, astronomers theorems. Astronomers theorems. And why do we call them so important? Because these are the first physicists who did studies on the subject of astronomy. So we say that the founders of these models, mean the founders of these theorems were the first astronomers. Were among the first astronomers, or the early astronomers, not just the first. That's not the good term. The early, okay, theorems were the early. The founders of these theorems were the early astronomers who did a lot of research on astronomy, on the astronomy. And wonderfully enough, for example, one of the astronomers, he was a mathematician. So that's why that when you are learning about physics, physics is not limited for the physicists only. You're a mathematician, they can be physicists. Okay? So let us discuss those three astronomers' theorems, and then we go to the third subtopic. Okay? The first astronomer, the first astronomer theorem is called the geocentric. So it's called the geocentric. Say it with me, geocentric. Again, say geocentric because if you pronounce, you get it in your mind. Or some of the references, they call it plotemic theorem. Plotemic theorem. Geocentric or plotemic theorem. This one is one of the astronomers' theorem. So the question is this: state geocentric theorem. State geocentric theorem. So I say that geocentric theorem state that this is according to what he formed. State that all planets, stay with me, all planets, the moon, you have only one moon, don't say that all the moon, the sun, right? Sun and the stars. And the stars describe a circular path. This according to this physicist. A circular path. Circular path. Describe a circular path about the S at the center. Please enjoy this lecture, enjoy this material, enjoy this secret of creation of the universe. Okay? Circular path, circular path about the S. About the S. Okay, about the S as the center. At the center. Okay, at the center of the system. Is the end of the story. So geocentric, say geocentric again. Geocentric or plotemic theorem state that geocentric or plotemic theorem state, no need for you to claim, you have just to understand. All planets, not one planet, all planets, the moon, the sun, and the stars describe a circular path. Just I'm underlining the keywords. Describe what a circular path about the S. About the S as the center of the system. Not about the sun as the center of the system, about the S of the Sioni. Don't see it. Okay, about the center 40, center of the system. Okay. Then, if you want to present this idea, because they use to produce the diagrams. This is the S. So this is the S. This is the S, which is the center of the system. And then we have what? The circular path. So this is the path, these are the orbits, we call them orbits. Orbits of all the planets. Also there we find orbits of the sun, orbits of the moon, orbit of the stars. Right? So this is the S at the center of the system. Then these are the planets. Planets orbits. You just see, say that these are planets 30. Planets orbit. Planets orbit. You don't know what the meaning of the word orbit, but I will teach you soon. So that is the diagrammatic, or this we call the Ptolemaic theorem. So he believed that all the other planets except the S, except 30. So this is we call the figure 1, and say that this is what is circular path of 14 of planets. That is about geocentricity theorem or Ptolemaic theorem. Again, we have the second astronomer's theorem, right? The second astronomer's theorem, we call it heliocentric. Heliocentric or Copernicus. Okay, or Copernicus theorem. Okay, heliocentric or Copernicus theorem. Say with me, heliocentric or Copernicus theorem. Remember that this just give us a term known as geocentrism, and this will give us a term known as heliocentrism. And the theorem is called the heliocentric or Copernicus theorem. Are you ready for that theorem? This is the way that it's stated. So you see that heliocentric theorem state that change. So heliocentric theorem state that all planets, describe elliptical motion. About the sun. Wow, this guy now he's approaching the truth about the sun as a center of the system. Okay, the center of the system at the end of his theorem. So let me give you a sketch, or his diagrams. You can also go online and see maybe some of the videos on how these theorems have been explained by those astronomers. Don't hesitate yourself to supplement these materials. Okay? I appreciate them. I used to learn from them. Even yourself, you may learn from them. So this is the elliptical path. Trying to draw the ellipse. You may draw maybe the good one compared to mine. That's not the case. The issue is just you have to sketch the ellipse. So this elliptical path of the planets. We use good drawing devices. So this is the sun, and this what we call them. All of these call them planetary orbit. Planets orbit. And this is figure 2. Elliptical path of orbits. So let me explain this theorem before you, so you can understand and master it own it from today onwards. Heliocentric theorem state that all planets, so I will be underlining, don't underline in exam if you be asked for the exam, don't do this underlining. This underlining is just I'm trying to simplify what are the keywords that you have to remember when you be asked about these terms. If you are good in English, you know if you know the keywords of stating a theorem or a law or even just defining the terms, then you can use your own words. Doesn't mean that you should cram the way it is. So I'm very bad in cramming, and even myself, I don't teach my students to cram. Okay? Maybe you can learn yourself how to cram. My intention, I teach geocentric. 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 Okay. So my intention is to teach students to understand, master the concept, and even do better than how I did myself. They have to be successful more than myself, more than the year teacher. Okay, all planets. We can start even with capital letter. It will really matter because it's the beginning of the sentence. All planets describe elliptical motion about elliptical motion. I think that I forgot some words. Describe elliptical motion about the sun as a center. Very good. About the sun. Got that keyword, very important. About the sun as the center of the system. As the center of the system. So all planets that you know describe elliptical motion about the sun as a center, not the S at the center. The S is the planet also. About the sun as the center of the system. So this is the diagrammatic representation. This is the sun at the center. This is the elliptical path. It's just like a structure of an egg. And this, we call them planets' orbits. Okay? Planets' orbits. If you have any question about heliocentrically, sure, don't hesitate yourself to ask in the comment section. If you join me right now, you're only welcome. My name is Olenjolai from Tanzania. Okay? I'm teaching you Astronomers theorems in gravitations at the branch of 40 of mechanics. Then again here we have something else to add before I go the 30 theorem. We said heliocentrism is so this is the astrometrical model in which the S, so maybe for example you can put this as a question. Question 3. You may find an exam to be asked like this one. Question 3. What is heliocentrism? What is heliocentrism? So is the astronomical model. Is a astronomical model, okay, in which the S and the planets revolve around the sun, at the center of the universe. At the center of the universe. At the center of the universe. And then another keyword, have to know to say that heliocentrism, okay, opposes geocentrism. Geocentrism. It's another keyword. And we explain a little bit about heliocentrism. So we say that this astronomical model, that's the first keyword, in which the S and the planets revolve around the sun as a center, at the center of the universe. And then heliocentrism, this physics opposes what he said from geocentrism. Geocentrism, he said that the Earth is the center and all planets revolve around the Earth. But heliocentrism said that the sun is at the center and then all the planets are revolving around it. Because, yeah, all the planets, even the sun is revolving around the Earth, which is not true. So this guy was true, but you will see as long as we continue the lecture. Don't be disconnected, so keep on watching. Okay, that is all about the second astronomical theorem. Again, we have the same theorem. In physics, we call it Tycho-Brahe. Tycho-Brahe theorem. Maybe my pronunciation might be bad or might be wrong, but don't worry about that. Pronounce correctly as you can. Tycho-Brahe theorem. Somebody called it, this is geo-heliocentric theorem. So in some of the books we call it, this is geo-heliocentric theorem. G stands for geo, H stands for heliocentric theorem. How does this theorem state? That's the question. Say that this is question 4. This was question 4, question 5. You can find the exam state the Tycho-Brahe theorem. Tycho-Brahe theorem. So Tycho-Brahe theorem, he said after his research, theorem state that all planets describe elliptical motion. All planets describe elliptical motion about the sun. As the center, as the focus of a system. This was the regions of Copernicus theorem. That's how it states. Tycho-Brahe, this is our Tycho-Brahe theorem. We explain it for you and to proceed. Tycho-Brahe theorem states that all planets, again I want to underline the keywords, all planets describe elliptical motion, not circular motion like geocentrism, about the sun as a focus of the system. So what he added, if you refer these three theorems, this guy he said that all the planets, the moon, the sun, the stars, revolve around the Earth at the center of the system, but in circular paths. Here we say that all the planets describe the elliptical motions about the sun at the center. Again, this guy said that, yes, he agreed with what heliocentric, but he added, it means he discovered another point which is very important, that the sun is not only at the center. The sun is not at the center, but the sun is act like a focus of the system. And this is according to the coordinate geometry, which actually that we use in advanced mathematics, and also coordinate geometry too, the advanced mathematics, and also use length for the ordinary diploma students. We means about the ellipse. We have a concept in mathematics called ellipse. So in elliptical paths, you can find that the sun is at one of the focus. The sun might be in either of the two focuses. So let me just draw the figure. So this is the figure. This is the Brahe figure. Suppose that it's elliptical motion or elliptical path like this. Then against you have another orbit. Another orbit. Against you have another orbit. I think that these two are enough to describe the concept. Okay? Can add more orbits. So suppose that this is the center. This is the center 40, center of the system, or center of the system. Right? And these are the orbits, or planets' orbits. Planets' orbit. So listen. So suppose that here we have an axis. And also even here we have another vertical axis. And this axis is just going to the orbits. Each orbit has its own axis. So listen. According to Tycho Brahe, he said that, yes, he agreed that all the planets revolve around the sun. But the sun is not here at the center. The sun is at the focus. So one of the focus will be on right hand side of 40 of the center. So this we call it foci, because it's on positive side in x coordinates, we call it the positive focus. And then the other one, this we call it another focus. Right? So this we call them, these are the focuses. So this is the focus point or focal point. We use lens about focal point. Even light. So this we call them foci because it's plural. Right? Foci is plural, focus is singular. So this is according to Tycho Brahe. And it is true because in our ordinary geography concept, we learn that sometimes the sun used to be near to the earth in some of the days, if you remember. So what does it mean? For example, if the sun is at this point, you find it is near the earth. And then if at this point we say that the sun is farthest from the equator. Yes? You remember that? So you say the sun now is in the farthest point from the equator or nearest to the equator. What the means of equator? Equator means that it's the center 40 of the earth. Right? It's a line that divides the earth into two parts, northern hemisphere and the southern hemisphere. So that's the concept. So this is figure 3. Figure 3, and then we say that the Theorem, this is we say that because for this one it's elliptical path of the we say that elliptical path path of 40 of planets and the sun at the center of the system. That's all about the second subtopic of Astronomers Theorem. We have 3 theorems that in gravitation. And I've told you, in case you have a question, don't hesitate yourself to ask in the comment sections of this video. And then we'll try our level best to answer, and even some other students in the world can try to answer your questions. Is it interesting? Do you enjoy physics? Yeah, physics is beautiful. So now, let me take you to the third concept, when we are going to learn about Kepler's laws of gravitation. So this I call it 5.3, when we have the concept known as Kepler's, say it with me, Kepler's laws. Kepler's laws. Even if you forget everything that I taught you today, remember this terminology known as Kepler's laws of 40 gravitation. Say, pronounce Kepler's laws of gravitation, because if you pronounce that, one of the technique, the teaching aids they call, God has given me. If you pronounce it frequently, 3 times, 4 times, 5 times, 6 times, then the terminology is written in your subconscious mind, and especially in your permanent memory, right? But if you don't pronounce, then you crab, you'll be singing. And it's a shame for you, like a YOS guy and a problem solver who is cramming even the terminology, the terms. Okay. So Kepler was astronomer, Johannes Kepler. So let me just give him a short introduction. Johannes, so his name was Johannes. Maybe even your name, who is watching this video, might be Johannes. Johannes Kepler. So if your name is Johannes, or even you who is watching this video, you can do more than what Kepler has done. Kepler did this 300 years ago. Okay? Johannes Kepler was a German astronomer. German astronomer. And he was born 1571. He lived until 1630 years, but he left an history, or he left a mark, he left a legacy in the planet. Even of today, we are studying his ideas. Okay, so was a German astronomer, made a detailed study, right? Detailed study of the motion, of the motion of the planets, about planets revolving about 30 about the sun. That's what he did. So he did a detailed study of the motion of the planets revolving about the sun. Then, after he did a lot of studies, the history said that in 1619, he had announced official now, he had announced the 3 laws. Fantastic. 3 laws. How many laws? 3 laws. How about you and I? How many laws will you start? Will you announce before this? Which govern the planet, the motion of the planets, Again, this man, in his studies before his death, he knew how the planets revolve around the sun, how the planets revolves in their orbits. This is the conclusion now for this literature. Orbits around the sun, okay, their orbits, but he did not know why they do so. Why they do so. Fantastic concept. He was astronomer. He did a lot of research. He used telescope to study the space. Then he learned that the planets revolve in their orbits around the sun at the focus of the system. But until he died, he didn't have an answer of this question. Why do planets revolve in their orbits around the sun? Why? That's the question. Why they do so? Why? So he left that question, and that's the goodness of the physics. And then God said, no, the world is not yet, God said that, no, the knowledge of the astronomy, the knowledge concerned about astronomy in the world is not enough. Then again, he sent his servants, whose names was Sir Isaac Newton. So Sir Isaac Newton answered this question that has been left by Kepler, by Johannes Kepler, the German astronomers. I think that you heard about Sir Isaac Newton. So I think that that's the first subtopic concerning about, in this topic I mentioned about Newton's law of universal gravitation. He answered these questions where they do so. So he took the study further. So even I and you, we have to research our area of interest and then see where the technology ends, where the knowledge has ended. Then we take it further. We answer those questions being left by our fathers. Not just having certificates and graduating and then celebrating and having jobs, being employed and whatever and so forth, and then we are thinking about to die. Sometimes I used to ask my students, what legacy are you going to leave in this world before you die? Some of them, they used to tell me that I will leave their kids. Nobody who is not leaving their kids, everybody is leaving kids. So that's not a legacy, it's not something new. Do something which make you speaking beyond of your days. That's one of my sentences I want to tell you. Regardless wherever that you have a focus, in medicine, in engineering, in science, everywhere you go, that make sure that you do something exceptional. That's why we are in this world, and that's why we are still alive. So then let us start now. Before just we start them, then we say that these three laws, these three Kepler's laws, right, are useful, right? These three Kepler's laws hold, okay, hold it for the motion, okay, for the motion of the both natural and the artificial satellites. Natural and artificial satellites. That's the very important applications of this. Three Kepler's laws holds for the motions of both natural and artificial satellites. So it doesn't describe only the solar system, but also give us a very important applications on the especially artificial satellites, where we have weather satellites, we have communication satellites, we have I think that the hundreds or thousands of the satellites right now in the space. So let us now start this business. Let us learn about first, say with me, first Kepler's law. First Kepler's laws. First Kepler's law. Say with me, first Kepler law. In some of the references, we used to call this one law of orbit. Law of orbit. As I have some references, we used to call first Kepler's laws or law of orbit. So the question which you can find even in exams, I cannot even, I use sometimes I forgot where. Which question did you end? Yes, sometimes I used to forget. So just to write the number of the question here. Okay? Question is, state. These are the common questions. These now are key points. State the first Kepler's law. Kepler's law of what? Gravitation. Of gravity. Remember, gravity and gravitation is they are similar. They are similar. This is law state that, okay? First Kepler's law state that the orbit of each planet, the orbit of each planet, the orbit of each planet is an ellipse. Number one is an ellipse. Okay, is an ellipse which has the sun at the center. Has the sun at the center, not at one of its foci, not at the center. Okay, there's the sun at the one of its foci. Foci is a plural, it's a focus. Is the end of the state. Or some references state this first Kepler's law by using other sentence or using another sentence, we say that the path of each of each planet. Okay, the path of each planet about the sun. About the sun is an ellipse. Is an ellipse. With the sun at the one of the one at one focus of the ellipse. Let me explain clearly this first law because it's very important. First Kepler's law said, first Kepler's law state that, or we call it law of orbit, state that the orbit of each planet, whether we have 9 or 11 planets, the orbit of each planet, is an ellipse. As the first sentence is an ellipse. Number 2, which has the sun at one of its foci. So this man, he answered first of all the questions that astronomers used to brainstorm themselves for a long time. That, okay, what the structure of the orbit? Is orbit a cycle? Is orbit an ellipse? Or is orbit just like a sphere? So he said that each orbit is ellipse, and he demonstrated practically. And then that ellipse, the sun is one of its foci, whether on left side of the center or right side of the center. Right? So that is the first Kepler's law. So the sun is an ellipse, so he said that yes, that's what I used to say. So what does it mean? When we draw, we say that this is the sun. It's just like a retrograde. This is the sun at one of the foci. Or I think that's better if I draw first the ellipse and then I introduce the sun. So suppose that is the ellipse of the first planet. This is the ellipse of the second planet. You may draw your ellipse correctly rather than what I do by using compass. So this is the ellipse. And then here I told that this we call it axis, which we call the major axis in conics. okay, in coordinates. Call it major axis, and this we call it minor axis. This the center. So remember that this dot, the center 40 of the orbit. And then I told you that these three, 1, 2, 3, we call them what? Orbits, planets orbits. 1, 2, 3. Call them what? Planets orbit. Maybe I'm acting like an obstacle to you, but I will leave this place and then so label it correctly. This is the orbit. This one we call it, I told you, let me just mention it, we call it major. This we call it in astronomy, we call this as what? Major axis. And then again, this one we call it minor axis. And then we say that this is one of the focus where we can find the sun. I put the first key plus now. First of all, this is elliptical. So remember, this is the planet's orbit, which shapes is what? Ellipse. Right? Then here we have the sun. So this is the sun. But also here we have again another point where the sun can be. And this one, both of them, we call it key. And this is figure 4.